Welcome, stargazers. If you will, picture a heavenly event so large that it obscures areas on Earth, readily apparent without any effort to hide. That is the scene we may be near. At the very edge of Orion's vision, the constellation star, Betelgeuse, is acting strangely, indicating a looming cosmic explosion that will illuminate our sky more than ever. However, when will Betelgeuse go supernova, and what will it look like? According to researchers, what secrets could this heavenly event reveal? Discover with us as we delve deeply into the details of what's actually the deal with Betelgeuse and the effect it could have on Earth, and possibly on an entire nearby planetary system. Found around 650 light-years from Earth in the Orion constellation, Betelgeuse is not merely a normal star, it is a red supergiant, quite possibly one of the most brilliant stars we know. It shines with a brilliance over 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out not only for its brilliance but also for its significance in human history and culture. Named after the Arabic expression Yad al-Jawz, which means the hand, Betelgeuse has been observed and documented by ancient civilizations for hundreds of years. It has been a guide for travelers and a mark of wonder for astronomers, its ruddy shade making it distinct from other stars in the Orion constellation. Can you imagine a single star that looms large over our entire solar system? To give some perspective on the sheer immensity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star achieve such huge proportions? At just 10 million years old, it is considerably younger than our 5-billion-year-old Sunday. However, Betelgeuse's enormous size means it burns through its material much more quickly, leading to a shorter lifespan than other stars. Now, this celestial behemoth, spanning a volume large enough to contain more than 1 billion of our suns, is approaching its final cycle. When stars of such size reach their twilight years, they don't just disappear, they exit with an extravagant flare. A cosmic explosion, a blast beyond human understanding in terms of energy and brilliance. This kind of event has the potential to dominate an entire galaxy, creating vast regions of brilliance across space. The last time Earth saw a supernova blast this close was in 1604. That event, known as Kepler's supernova, was the last supernova visible to the naked eye in our Milky Way galaxy. It remained visible for more than half a year, more brilliant than any other star in the night sky and even visible during the day for several weeks. What secrets do these heavenly remnants uncover? Ancient documents from various human civilizations, including Chinese and European astronomers, recorded the appearance of this new star. Evidence of this blast remains in the form of an expanding debris cloud, still observable today with advanced telescopes, giving us insights into the violent ends of massive stars. Supernovae are rare for Earth observers. But imagine, for a second, a stellar explosion so intense that it rivals the brilliance of a full moon, casting shadows on Earth at night and even being visible during daylight. The radiation from such an event could charge our atmosphere, possibly affecting satellite operations and even the climate. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for just such a grand display. Could we be on the edge of witnessing one of the universe's most dramatic events? Just recently, astronomers made a surprising discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and skywatchers worldwide. Known as the Great Dimming, the star's brilliance, which had been stable for centuries, began to decline significantly. This sudden change was so noticeable that even casual stargazers could see the difference when comparing Betelgeuse with other stars in the Orion constellation. This suggests that we may not be hundreds of years away from seeing its supernova blast, perhaps only a few decades, or even less. By April 2023, cosmic observations reported that Betelgeuse had returned to its normal brightness levels, leading many to believe that the anomaly had ended. In a stunning twist, the following months saw Betelgeuse's brightness intensifying by an astounding 50%. Such dramatic fluctuations, while typical of variable stars, were unexpected for Betelgeuse, which had mostly shown predictable luminosity cycles. This sudden and extreme surge in brightness put the star back into the spotlight, igniting discussions about its future. But what caused this sudden change in brightness? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly throw a cosmic curveball? Stars are not just shimmering spots in our sky, they are dynamic entities with life cycles, behaviors, and mysteries of their own. Some celestial bodies undergo periodic brightness variations, much like the changing of Earth's seasons. Throughout its stellar lifetime, Betelgeuse has maintained a relatively consistent 400-day brightness cycle. However, the Great Dimming appeared to defy this pattern, challenging our understanding of cosmic phenomena. So, are we getting close to a cosmic revelation? While the precise reasons behind Betelgeuse's anomalies are still under investigation, a compelling hypothesis has emerged. This hypothesis focuses on stellar activity and mass ejection. Picture Betelgeuse as a massive celestial volcano, quietly expelling vast amounts of its material into space. Recent data from the Hubble Space Telescope revealed that Betelgeuse had recently ejected a tremendous amount of surface material into the universe. This ejection, 400 billion times larger than the mass typically released during similar solar phenomena, was equivalent to several times the mass of our Moon. Such events can result in the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more difficult to observe. As this dust began to dissipate, driven away by the star's radiation pressure, the veil lifted, possibly explaining Betelgeuse's return to normal brightness. One way or another, these events suggest a star that is far from done astonishing us. Many speculate that Betelgeuse is approaching the twilight of its life, with a supernova event, a sudden burst of energy capable of eclipsing an entire galaxy, on the horizon. This phenomenon occurs when a star undergoes a sudden change in its core. Such changes can arise if a star absorbs too much matter from a neighboring star or, in Betelgeuse's case, from the exhaustion of its nuclear fuel. This overflow of mass into the core sets the stage for a catastrophic collapse. But what ultimately drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse begin their journey by consuming hydrogen in their cores. This initial phase, known as the main sequence phase, lasts for billions of years and forms the foundation of a star's life. As stars near the end of their hydrogen supply, they expand, adopting new energy sources. In Betelgeuse's case, once the hydrogen depletes, it begins burning helium, leading to the formation of oxygen and carbon. This transition marks its evolution into a red giant. If this prediction holds true, Betelgeuse could be on the brink of a dramatic end, one that will redefine our understanding of stellar death. But when exactly will this happen? That remains the biggest mystery. The countdown to a supernova. Astronomers estimate that Betelgeuse could explode within the next 100,000 years, but recent anomalies suggest it could happen much sooner, perhaps within our lifetime. Unlike other supernova candidates, Betelgeuse is relatively close to Earth, making it an ideal case study for scientists eager to witness such an event firsthand. A Betelgeuse supernova would be a once-in-a-lifetime cosmic spectacle. When it does explode, it will likely outshine the full moon, casting visible shadows at night and being bright enough to be seen during the daytime for weeks. The sheer intensity of the explosion will send shockwaves across the cosmos, creating a dazzling nebula that will persist for thousands of years. However, despite its power, Betelgeuse's explosion poses no direct threat to Earth. While supernovae release vast amounts of radiation and energy, Betelgeuse is simply too far away, about 650 light-years, for these effects to cause harm. The explosion will be an awe-inspiring sight but not a dangerous one. What happens after the explosion? Once Betelgeuse goes supernova, its fate will depend on the mass left behind. There are two main possibilities. 1. Neutron star formation. If the remaining core is between 1.4 and 3 times the mass of the Sun, Betelgeuse will shrink into an incredibly dense neutron star, an object so compact that a teaspoon of its material would weigh billions of tons. Neutron stars are among the strangest objects in the universe, with intense magnetic fields and rapid rotation. 2. Black hole formation. If the core exceeds 3 solar masses, gravity will overwhelm even neutron pressure, collapsing Betelgeuse into a black hole. This would mark the birth of a gravitational abyss from which not even light can escape, a fascinating and eerie conclusion to the life of this brilliant star. A cosmic reminder. Betelgeuse's imminent demise reminds us that the universe is constantly evolving. Stars are born, they live, and they die, shaping galaxies and even the very elements that make up life itself. The carbon in our bodies, the oxygen we breathe, all of it was once forged in the heart of an ancient star like Betelgeuse. While we may not know the exact moment Betelgeuse will explode, one thing is certain. When it does, it will be one of the most spectacular astronomical events humanity has ever witnessed. Until then, all we can do is watch, wait, and marvel at the mysteries of the cosmos. Every few years, once its carbon reserves are exhausted, but not all researchers agree, studies from Hungary's Konkoly Observatory suggest that Betelgeuse is still around. When it was first burning helium, a fact that seems to be agreed upon by all scientists, despite these disagreements, Betelgeuse is set to become the Milky Way's next supernova. However, determining the timing of this event remains a vast guessing game, with estimates ranging from just a few years to 100,000 years. Amid these discussions in science and speculations about Betelgeuse's future, one fact remains unchallenged: the very nature of our observations. When we look up at the starry sky, there's a subtle paradox we often overlook. This paradox lies in the very concept of time, stars, and light in our vast universe. Since celestial bodies are so far away, their light takes an immense amount of time to reach our eyes. For example, the speed of light, though a formidable 186,282 miles per second, still has its limitations. Consequently, the light from distant galaxies and stars takes time to reach us as it navigates the vast expanse of space. When looking at Betelgeuse, you're actually seeing a spectacle from 650 years in the past. To put that in context, when this light began its journey toward Earth, the Renaissance was just unfolding, and adventurers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through an immense time capsule that provides glimpses into the distant past. If Betelgeuse had already burst into a brilliant supernova, we wouldn't be aware of it for another 650 years. So, while we study and predict its impending supernova, somewhere out in the vast universe, this amazing event may have already unfolded. We're simply waiting for it to traverse the distance and reach our eager telescopes. Recent discoveries surrounding Betelgeuse have sparked intense conversations within the astronomical community. Investigations have turned to another shocking revelation from the recently observed SN 2023X. This supernova, occurring in a galaxy adjacent to the Milky Way, reminded many of the fascinating dynamics and mysterious nature of the universe. SN 2023X was unique in its own right. Found millions of light-years away, it displayed an intense burst of brilliance that instantly outshined its host galaxy. What made it particularly interesting to researchers and casual observers alike was its uncanny resemblance to what many expect will be Betelgeuse's fate. The distance, power, and effects of the explosion provided an enticing glimpse of the processes that these massive stars undergo as they approach the end of their lifespans. For many, SN 2023X served as a preview of what might happen when Betelgeuse meets its fiery fate. The sequence of events might look similar to what was observed with SN 2023X. Moreover, the connection between these two celestial events highlights the greater interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova like SN 2023X, these cosmic events remind us of the dynamic and evolving nature of space. Beyond the physical and astronomical implications, such an explosion would have significant consequences for human culture. The sky, noticed and admired for centuries, would change, leading to reflections on impermanence, the immense scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the ephemeral nature of existence and our eternal journey to appreciate the magnificent past. As we contemplate the potential supernova of Betelgeuse, it's essential to understand the broader implications of such an event on our cosmic neighborhood. When Betelgeuse finally meets its explosive end, it could impact not only our immediate vicinity in the Milky Way but also the dynamics of the interstellar medium. The shock waves produced by the supernova will create vast regions of ionized gas, enriching the surrounding space with heavier elements forged in the star's life cycle. This process plays a crucial role in the grand cosmic cycle of matter, fostering the creation of new stars and planets containing the necessary elements for life. Furthermore, the light from the explosion could serve as a cosmic laboratory for astronomers. By studying the light curve and spectral features of the supernova, researchers could gain invaluable insights into the life and death of massive stars. Every supernova provides a novel window into the physical processes at play, revealing how energy is distributed in such cataclysmic events. By studying these phenomena, scientists can refine models of stellar evolution, contributing to our understanding of the universe's life cycle. Beyond scientific discoveries, significant cosmic events have historically influenced art, literature, and philosophy. The brilliant appearance of Betelgeuse's explosion would likely inspire a new era of artistic expression and reflection. People across the globe would gaze up at the night sky, contemplating their place in the universe. This occurrence could spark renewed interest in astronomy and science, much like the curiosity that emerged during the Renaissance when observations of the heavens began altering our perception of the universe. From a practical standpoint, the effects of a supernova could extend to technology. Increased radiation levels from such an explosion could pose challenges for satellite communications and navigation systems. These implications would require advancements in shielding and protective technologies, pushing the boundaries of engineering and space exploration. As we continue to rely more on technology, understanding and adapting to these cosmic events becomes essential for mitigating their effects on our daily lives. The supernova could also alter our perspective on time itself. The event's fleeting nature serves as a reminder that even the most monumental celestial bodies are not eternal. This realization might prompt philosophical discussions about existence and the transient nature of life. The universe operates on timescales that dwarf human lifespans, yet we find meaning in our brief moments under the heavens. As we stand on the precipice of a new astronomical era, Betelgeuse's inevitable fate serves as both a scientific milestone and a philosophical reminder of the universe's impermanence. The anticipation surrounding its supernova highlights humanity's ceaseless curiosity and our desire to witness the extraordinary. If Betelgeuse were to explode within our lifetime, the event would be one of the most significant celestial spectacles ever recorded. For weeks or even months, its brilliance could rival that of the moon, casting shadows at night and dominating the sky. The sudden change in the familiar celestial landscape would captivate both professional astronomers and casual stargazers alike. In a way, this unfolding cosmic drama mirrors humanity's broader quest to understand our place in the vast expanse of the universe. We are drawn to moments of cosmic transformation, not only because they offer insights into astrophysical processes but also because they force us to confront the passage of time on a scale far beyond our own existence. The death of a massive star is not just an astronomical event, it is a story of destruction and creation, an echo of the past shaping the future. The heavy elements forged in Betelgeuse's fiery demise will eventually find their way into new celestial bodies, forming the building blocks of future stars, planets, and even life itself. As the countdown to Betelgeuse's supernova continues, whether it is a few years, a few centuries, or thousands of years away, each moment we observe it serves as a bridge between past, present, and future. The star may already be gone, its fate sealed long before we can witness it, yet its final light is still traveling toward us, a silent messenger from an era long forgotten. Ultimately, Betelgeuse's supernova will remind us of one undeniable truth: the universe is in constant motion, a vast and dynamic theater of birth and destruction. And in this ever-changing cosmos, we are both observers and participants, forever searching, forever wondering, forever looking up.